Example 2, simplify the following. We have part A, B, and C. So in these examples here, we are going to apply another rules that we happens to encounter in the rules of surd, where when the time I have the situation of square root of A multiplied with B, then I can split it to become square root of A multiplied square root of B. We are going to apply these rules here to help us to solve the following questions. Of course, later in part B and C, we need to have the knowledge on addition and also subtractions. But at this moment, for question A, we need to have a quick look on how to apply these properties. And please bear in mind, there's a reason why we want to break the numbers inside the square root into the multiplication of 2 squared, where in this attempt here, we try to reduce the square root, make it become something look simpler, where in order to achieve that, what we do is that between the 2 square root that we break out, one of them is supposed to be something that we can convert into integers. That means either A or B, either one of them, it happened to be able to produce to us a perfect square number. So what is happened to be perfect square number is like 1, 4, 9, 16, so on and so forth, which is 1 square, 2 square, 3 square, 4 square. So these are the numbers that we are trying to take notes. Of course, the 1 is not really meaningful in the calculation here. So one of the A and B, it should be a perfect square number in order to simplify it. So let's have a quick look on questions A, square root of 8. So think about it, about the number 8. Number 8, I need to consider some number multiplied with another number, I can get 8. And one of them must be perfect square number. And in this case, it is very obvious. I will have 4 multiplied with 2. 4 is a perfect square number. So as a result, square root of 8, I can break it to become square root of 4 multiplied square root of 2. And once again, we notice that square root of 4 can be rewrite as 2. So become square root of 8 is equals to 2 square root of 2. Of course, this thing here, these calculations here can easily done by using your scientific calculator, but let us see the concept behind using the rules. B, 5 square root of 3 minus 27. So between the 2 square root term that we have, usually we will refer to the one with the content which is larger. And the smaller one is as if like a guideline for us to take notes. Can we change both of them happens to have a common terms within the square root? Sometimes it's not as direct as this case here, where we can see I convert 27 something to do with square root of 3. But we need to think about what do they have in common. So you notice that 3 and 7, I can change, 3 and 27, I can happen to take notes that 27, in order to have the common square root, that means maybe, I say maybe is because maybe the common square root that I choose, it may not be helpful. For example, I suspect one of them I must have 3. The other one, it depends what is multiplied with 3, so that get 27. Just now I say that this consideration may not be helpful is because if let's say I consider 3, but the other number I multiply is not something that happen to be perfect square number, then sorry, we need to think about other combination, other surd as a foundation to do the simplification. So in this case here, I notice that 27 is 9 multiplied 3. So 9 is a perfect square number. So as a result, I can convert 27 into square root of 27 into square root of 9 multiplied square root of 3. And as a result, this is what we happen to have initially. Then next, we simplify. Square root of 9 we simplify, become 3. And now the next step, you find out I can further simplify these subtractions where I see that the square root terms, square root of 3 is in common. So it can simplify, become 5 square root of 3 minus 3 square root of 3 become 2 square root of 3. So this is the result I have. And once again, if you use your scientific calculator, it will give us direct answer. But in here, we try to, without using calculator, to see the concept, to see the rules behind. Okay. C. C is also a simple example. So, square root of 2, square root of 72. So, we see that we have a larger square root is on 72. The smaller one is square root of 2. And this square root of 2, I cannot even break it into a smaller square root anymore. So, it gives us the hint that 72, the number inside this larger square root, must have something related with the number 2 in another square root. So I suspect that it should have something multiplied with 2 is the one that we're looking for. And this number here is supposed to be a perfect square number. And let's see. We notice that 36 multiplied with 2, I get 72. So I'm going to break 72 into 36 multiplied 2. And let's check. Coincidentally, again in this simple example, 36 is happen to be a perfect square number. And the next thing we can see now is that if we identify 72 can break into 36 multiplied with 2, again apply the rules that we learned in the square roots, you find out that square root of 72, I can break it become square root of 36 multiply square root of 2. Then the next line, what happened is that you will see square root of 36, I simplify become 6. Recall back the knowledge that happens to find out in the previous part. You happens to see that when the time you do multiplication involve of square root, we only focus multiplication among the square root itself and among the integers outside the square root itself. And in this case here, the calculations, 3 multiplied 6 square root of 2, it will just equals to 18 square root of 2. The terms in front, 12 square root of 2, it doesn't have any changes, just maintain only. And yet, if let's say you still have problem to catch what is going on here, think about this. 3 times 6 times y, where the square root term you treat as if like the unknown in algebra, and you know that 3 times 6 is 18, the y is still maintained. So this is the idea what is going on. And next, as a result, you see the addition, common square root. So 12 plus 18, I have 30 square root of 2 as my final answer.